Hey everyone, today we will be discussing CodeChef Starter 214. So let's start discussing with the first problem. The chef is playing with two standard six-sided dice. After rolling dice once, chef observes the number appearing on them. You are given two integers a and b, the number shown on first dice and the number shown on second dice, and your task is to determine whether the numbers shown on both the dices are same or not. If they are same, then print yes, else print no. So this is just computation problem where if the two numbers given are equal, we need to print yes, and if they are not equal, print no. So just write if else statements. So this is it for the first problem. We are checking if the two numbers appeared on dice are equal, then print yes, else print no. So this is it. Now let's move to the second problem. Chef lives on position X on X-axis. Chef has two Y friends, each living at every integer point in range X minus Y to X plus Y, except the position X itself. Chef wants to visit his friends, but his mother has placed a strict rule. Chef is allowed to travel to at most Z unit away from his house in either direction. This means Chef can only move within interval x minus z to x plus z. You need to determine how many of Chef's friends live within the range Chef allowed to travel. Okay, so the problem statement states that Chef lives on a number line. The center of it is x, where Chef lives. Alright, now there are two boundaries, both on positive side and negative side of x. So let's, for ease, consider that x is our origin now. Alright, so x minus y and x plus y are symmetric now. So the condition hold for right part will be hold this as same for the left part. So let's see what is the condition for right part only. Let's say chef is having friends up till y, and his mother has placed a restriction to visit up till z. So what is the maximum number of friends chef can visit in the first axis? It will be equal to z minus x. Right. Now in the second part, what is in this case, we note that y was greater than z. So the restriction restricted chef to visit up till z only. Alright. Now what in the other case? The other case, what if this was z and this was y? Okay. So chef had friends up till y. So what is the maximum number of friends he can visit? It's obviously y minus x. He can visit all his friends. And the same condition holds for y-axis as well. So whichever is smaller, if y is smaller or z is smaller, that puts restriction on the number of friends Ceph will visit. Alright. And what is the final answer? It is 2 times of computed result because we are considering both positive x-axis and negative x-axis. So what is our final answer? Our final answer is computed as 2 times max of, or sorry, min of y minus x comma z minus x. Alright. Alright. This is the case when y was a coordinate. Alright. Y was a coordinate. But in our input, what is y given as? Y is given as the distance up till which chef can travel. So y minus x is what we are given with. So we need not compute what is the distance now. So answer is 2 times the minimum of y comma z. Right. This is what we have printed and the solution is accepted. Now let's move to the third problem. So Chef has an array of length n. Initially all the elements are 0. Chef wants to transform his array to a permutation of length n. Chef performs the following operation any number of times. Select the indices or index, update the value of ai to ai plus 1. Now for every operation, the cost of operation is computed as z, and z is the number of different indices such that both such that both a at j and a at j plus 1 are 0. Right? This means the cost is equal to all such indices such that that index and the next index are 0. So what will chef do? Let's understand the problem statement carefully. Like all the elements initially are 0. Alright. Then chef wants to convert it into a permutation. And in each step, the cost is he can either increase the element by 1, he can just increase the element by 1. Alright. And what is the cost of this step? It is equal to the number of index where that index and the next index are having value 0. Let's say he chose first index. Then what is the array transformed as? It is transformed as this. So this particular index and its neighbor are both 0. So cost plus 1. This index and its neighbor are 0. Cost plus 1. This index and its neighbor are 0. So cost plus 1. Similar for this. So what is the total cost? 1, 2, 3, 4. Okay. These are the 4 indices. Now we need to minimize the cost. Alright. What is the best way uh, so that cost gets minimized in a single step? Like let's say if we had inserted 1 here, then there is a restriction placed on only this particular index. Alright. Because it's this particular value itself changes to 1. So cost minus equal to 1. What for other indices? The cost remains same. But what if we had chosen this index? Alright. Here, this index and its neighbor are not both 0. Its right index is 0. So cost minus is equal to 1 for this. And for this, this index itself is not 0. So cost minus is equal to 1 again. So this operation gives us the criteria of cost minus is equal to 2, while this operation gives us of criteria of cost minus is equal to 1. So what happens in the next condition? If we converted this element, then cost minus is equal to 1 again. Alright. But if we converted this index, alright, this index has a neighbor which is 1, and this index itself is 1. So again, cost minus is equal to 2. So did you realize that what we are doing? We are inserting 1 in all alternative positions. Alright, starting from 2. First inserted on 2, then 4, then 6. And what is the cost for each operation? Let's say inserting 1 here blocked this element and blocked this pair, blocked this pair, and it blocked this pair. So what is the total number of pairs remaining? The last element cannot contribute to a pair. Alright, so total 2 are subtracted because of this one's insertion, and 1 cannot form a pair. So there are a total of n minus 3 pairs. Similarly, for the next test case, 1 is subtracted here, another is okay. These two pairs were already subtracted in this case. Now, what are the new pairs that are subtracted? It is this pair because it was 0 0 here, and this pair because it was 0 0 here. So now again minus 2. So cost is equal to n minus 5 here. So till which case this particular pattern will continue unless and until this particular cost changes to 0. After that, like no cost will be required. So this gives us conclusion that our answer is equal to summation of n minus 3, n minus 5 up till it reaches 0. Alright, so let's implement it in our code. What are we given? Just an integer n. And what is the initial cost? It is n minus 3. While cost is greater than 0, add the cost to our answer. And what about cost? Cost is minus by 2 in the next step. At the end, print the total cost required. That is it. Uh, this solution is accepted. Now let's move to the next problem. It is crazy permutation. So in this, Ceph has two permutations, A and B of length n. Here, a permutation is an array that contains all unique elements from 1 to n. So Ceph wants to transform A into B. Alright, so we want to transform A into B using operation any number of times. What is the operation? Choose an index I and either increase AI by 1 or decrease AI by 1. However, after every operation, the following condition must never hold. The condition is that the any two neighboring elements, AI and AI plus 1, should not be equal. Intermediate values may become any integer. They do not have to remain in 1 to n, and A does not have to remain a permutation. But finally, the array must be equal to B. Okay, what does the problem say? Problem say that we have two permutations. Let's say this and this. Alright. Now we want to convert this permutation to this permutation. Now what are the operations? Let's understand the operation in detail. We can either increase any index by 1 or decrease any index by 1. But what is a constraint? The constraint is that if we try to increase this 1, then it becomes 2, 2, 3, 4, 5. Now these two elements, a pair of two consecutive indices, have become equal. So this is not a valid operation. Alright. While if we had decided to subtract it by 1, then uh, this is a valid operation. Alright. So this is what the problem is. Now let's understand some observations. Let's say a number is A, or let's understand what are the operations that are actually not possible. Alright. So let's say we had 1, 2 and 2, 1. Alright. Now understand this thing. Whatever we try, if we just keep increasing this 2 to, let's say, a very large number, which this is our target. Let's highlight everything. Target is 2, 1. Alright. Now let's increase this second number by a very large number. Alright. Now let's make this 2 so that we are safe and reach our final state. Alright. So it gets transformed to 2, 5. Now if we try to increase this number, then we eventually go like 5, 5 transforms to 4, 2, 4, 2, 3, 2, 2. At this position, we note that these two numbers are equal and this is an invalid operation. So we can never transform 1, 2 to 2, 1. Why? Because the first number, let's say initially 1 was smaller than 2. Alright. Now 1 increases to get transformed to 2, and initially 2 was greater than 1. Alright. So if we, what is our requirement? For a pair, requirement was to increase one number and decrease one number. Alright. And we saw that during this increasing and decreasing operations, conflict appeared. Conflict was that without getting equal numbers, we can never change uh, one number into another. Alright. Without equal neighbors, transformation never possible. Is it that this condition will always hold? That is, if first number of pair is to be increased and second is to be decreased, then will the answer always be impossible? That is not correct, because let's say 1 is to be transformed to 2 and here it was 5 and it is to be transformed to 4. So this is a correct transformation, because 1 can just increase by 1. Alright, and 5 can just decrease by 1. And this is the correct transformation. Let's say the rest of the array was same. Alright, rest of the array do not matter. So if during transformation, what is our observation till now? The first observation was that if we have to increase the first number in pair and second number in pair, we have to decrease, then transformation is not possible. But it is not correct for all the cases. It is correct for cases when the pairs have to be equal to each other to transform. Alright, so let's just implement this condition in our code. Alright, sorry. Um, so this is it. For every pairs that we visit, so let's understand one more thing. Like for this condition, we just increased 1 and decreased 5. Alright, so what about the rest cases? Like if we have to just make it a permutation, then this should be transformed to like 4 has already been used, then 1 and 5 are remaining. Alright, so we see that one condition told us that transformation is possible, but because it is a permutation, we see again that transforming. Wait a minute. Alright. So our previous observation was that this should be correct for all cases to be transformed, and while reversing or while transformation, the first number should never collide or conflict with the second number. So how can we write this in form of a mathematical expression? Let's say AI was initially greater than the next element, and BI requires it to be smaller than the next element. Right. If this is the condition, or the reverse is the condition, AI was initially smaller and BI requires it to be great. So actually, for this particular condition, transformation is not possible, because while increasing, we end up in a situation where both of these neighbors have to be equal sometime. Alright. So let's implement it in the code. So for every pairs, we need to check the following. If our current element was greater than the requirement is reverse. Alright. The parity has parity, not actually parity, the greater than symbol has been reversed. Then this leads to our answer being false. And the reverse as well. This is smaller and the requirement is to be greater. Alright. If flag, then print yes, else print no. Alright. So this is it for this problem. Let's move to the next problem now. So problem's name is delete for fun. We are actually given a circular binary string of length n. That is, position 1 is adjacent to position 2 and position n. That is, just the binary strings are placed in a circular table. And in general, position I is adjacent to I minus 1 and I plus 1 taken mod with n. Alright. You are also given a starting string k. You must delete all n characters from string one at a time, following these rules. Your score starts at 0. The first deletion must be character k. After deleting a character at some position p, the next deletion must be from any of the two characters of that are currently adjacent to p in remaining circular structure. Let the character deleted on ith move be c. Then, if c is or if I is odd, that is, we have performed I operations and I is odd, then add C to our answer, else subtract C. For every deletion, including the last one, your score must remain strictly positive. So let's understand the problem in detail. Like for a circular table, let's say some elements are present, 0, that are binary, alright. So what does circular mean? This is the first index, this is the second index, this is the third index, fourth, fifth, sixth. Alright. So 1 is a neighbor of 6 as well as 2. This is the meaning of circular table. So let's move to the problem now. So we are given with an array which is made up of zeros and ones. Alright. And we are given the starting point. Let's say this is the starting point. Then it is necessary that starting point must be removed at first. So at first starting point will be removed, then array will be concatenated. Now we can either start from this or this. That is, we can either pick this value or this value because it is the neighbor of the just initially removed value. Right? This was removed, then in the next step, this can be removed or this can be removed. And what is the score of removing that index? The score is equal to, if the current turn is odd, like this was the first turn and the value was 1, so 1 is added to our score. Now if we had chosen this one, then this is the second turn and we have chosen 1, so 1 is subtracted from our answer. Alright. So what is the requirement? The score must never be smaller than equal to 0. Okay, it should never touch 0 or shouldn't be negative. So understand one thing, like let's say the value of index k is equal to 0. Alright. In this case, the initial score will be 0. And this tells us that uh, this particular scenario will always be losing scenario. Alright, because score can never be less than equal to 0. What if let's say we are considering k minus 1 here, k here, and k plus 1 here. Alright. So what if this is 1? So for a possible winning scenario, this should be 1, and that is guaranteed. Now, what if one of the neighbor is 0? Let's say what if both of the neighbors are 1? Let's understand what if both of the neighbors are 1 and zeros. In the next step, we see, so I say just a claim, just remember this. We will prove this later on. If we take our score to 2, then we always win. Just memorize this thing or use that black box now. We will prove this later for sure. But just aim to take our score to 2. Alright. Now what are the possible scenarios? K is fixed as 1, which is required. Now what if both of the neighbors are 0? And what if both of the neighbors are 1? If this is the scenario, then in the first step, pick k, score is equal to 1, pick k plus 1, score is equal to 1 again, because 0 subtracted from 1 is 1 again. Now pick k minus 1, then score is 2. Alright, because we picked this first step, so add 1, this second step, so subtract 1 minus 0 is 1, then this third step, so add, so score is 2 at the end. Our initial aim is to make our score 2 at least. In this scenario, what happens? We pick k, score is 1. In the second step, we just pick any of the neighbors because both of them are 0. Pick any, score is still 1. Now, what is the possible scenario after that? What are the values that will be arriving? Like we know 1 0 is for sure available. Now, if we had picked this 0, then maybe again next element is again a 0, and maybe the next element after it is 1. So what do? We picked this in the first step, score is 0, score is 1. Now we pick any of them. What happens to the score? Score is same. Alright. Now what if this 0 again appear? Now this is the third step. The score is to be added. So add this 0 itself. Score is again 1. Now we see that 1 is destined to appear. Alright, at the end. If all the values are 0, then pick them all. And at the end, we have final score as 1 and we just win. But what if 1 appears? Just pick all these zeros. Then if our turn is odd, then pick this 1. If our turn is even, then pick this 0 to the left and then pick this one. Alright. In this way, our score is 2, at least 2. And we have black box in our mind that if we can make our score 2, then we always win. If you did not understand this construction, let's understand it again. Like we know that 1 appears to the right of one of the neighbors. Alright, let's say right neighbor. So first pick this 1, score is 1, then pick any of these zeros. Let's say we pick this 0, score is 1 again, then pick this 1. Unless pick all these zeros, unless and until we reach this one. Alright, and at the end, we have picked only zeros, so our score is 1 again. Now, let's say when we reach this 1, our turn is odd, then our score will be added. So score will be +1 equal to 2 now. Now, in the other scenario, it is even. We know that this particular 0 is still remaining for us. Alright, so pick this 0 now. Turn is odd now. Alright, now what happens if we pick this 1? Our score is +1, which is equal to 2. Now, what about this scenario? This third scenario. In this third scenario, uh, like these are the neighbors. All right, k was destined to be 1 initially, otherwise we would always lose. So 1 1 1 is the scenario left over. So what can we do now? For first turn, pick this one, score is 1. All right, now in the second turn, pick any of these. All right, either the left neighbor or the right neighbor. Whatever we pick, we get -1. All right, score is equal to wait a minute, wait a minute. All right. So for this 1 1 1 scenario, whatever we pick, the left neighbor or the right neighbor, our score is -1. So this is equal to 0. And this proves us that, or that this says us that we lose in this scenario. So if this is the scenario, we reach the score 2. If this is the scenario, we reach the score 2. And if this is the scenario, we lose always. So losing conditions are clear by now. If the kth element is 0 itself, or the kth element is 1, but both of its neighbors are zeros, alright, then we always lose. Now, in the rest cases, we always win, but our claim needs to be true for that. Let's say our claim was, if we take our score to 2, then we always win. Let's say our score is 2. Like we have completed this portion somehow, and score is 2 now. Now, if we have zeros and ones, if our turn is odd, pick this one and then this 0, our score add increases by 1. Alright, pick 1, then 0, score plus plus. What if both zeros? If the other scenario was turn was even, pick 0, then 1. So score plus plus again. Alright, because when we picked 0, it needed to be subtracted, score remained same. Then we picked 1, score plus plus. Alright, so what if both of these were 0? Then pick any of them in any step. Score remains the same. So score remains same. In the third scenario, we have 1 1. Again, for this scenario, pick any of them. First pick 1, then our score is at least 2 now, which transforms to 1, at least 1. Then pick this 1 again in the odd trial, which gives our score 2 again. Alright, score is 2, let's say. If turn is odd, pick any of them in any order. Alright, whatever is the turn, pick any of them in any order. Answer remains same, or score remains same, because +1 and then -1. Score is same. Score is equal to +1 and -1, or -1 and +1, alright, is equal to same. Alright. So we come to a conclusion that whatever number appears at this point of time, we have a construction of picking both of the neighbors. First the left neighbor, then the right neighbor, uh, according to whatever our turn is. Then we can always keep our score at least equal to 2 by just picking up the two neighbors that are present to left and right. So this is it. We have also proved our claim. If we have score at least greater than equal to 2, then we always win. So let's implement it with the following algorithm. What will be our algorithm? Start from k. If k equals to 0 or both neighbors are 1, then we always win, always lose. But in the other scenario, keep the indices of next available, keep the next available indices. Both to the left and to the right. Now, according to the scenario, if our condition is odd, then try to pick 1. If we are not able to pick 1, uh, then both of them are 0. Alright. If not 1, that is 0, and this was our uh, part that was completed, and both of them are zeros. So this condition is here, and the score remains same. Alright. If even, then try to pick 0. If no 0, that is 1 and then 1. Then this condition tells us that score will remain same. So in both of these cases, pick any. Right. So at the end, the indices we have chosen are needed to be printed. Print the order. Alright. So let's move forward to the implementation part. So we have n and k size and starting points. We took string as input. Now just subtract the k because our, let's say, ordering will be 0 based. Now if the kth element is 0, alright, we are sure enough that we cannot get an answer. Now let's say the left element is, because we have already picked up k, the left element is k minus 1 modulo n, and the right element is k plus 1 modulo n. Alright. What is our choice number? Choice number is 2 because we have picked k already, so second choice. Now what is our current score? Because we have picked 1 in odd, so current score is 1. Let's have an answer array which will store the order in which we are visiting. So k is 1 base to be printed, so k plus 1. Now, unless and until this L and this R are equal, that is, the array has only one element left, do this operation. Like if choice is odd, if the left one is 1, we are just finding for 1. Answer pushback n plus 1, and L is transformed to 1 minus. Right. What if the right element is 1? If any of them is 1, just pick it because it increases our score. Alright. If both of them are zeros, then score remains same if we choose any of them. So just pick the left one. Alright, pick any of them. Now in the else part, what is the else part? Current choice is even. Alright. So if the current choice is even, try for 0. Like just copy paste this thing, and here we are trying for 1. Here we will try for 0. Alright. If none of them is 0, then it is a 1-1 scenario. And we said in 1-1, score will always remain same. What if, so we have still not changed the score in both of these scenarios, our current score will increase, alright, because we have chosen a 1. And in this scenario, because it is even and we have chosen a 1, so curve will decrease, alright. But maybe curve decreases up to 0 or negative. So for that case, just print -1 because answer is not possible and return. Alright. At the end, just make sure after every operation, choice is changing. And now we are left with just one single element. What is it? L plus 1 or R plus 1. That is lth element or rth element. Now, if the current element is 1, then only curve will change or like increase or decrease. If choice is even or let's say odd, then curve increases. Else curve decreases. And by decreasing, it can go up to negative. So check this condition again. If goes to negative, just return. Now iterate over all the elements of answer and then just print it. This is the order. So this is our solution for this question. Submit it. Okay. Some issue. Let's debug it. k minus 1 plus n, because uh, we are subtracting, or let's say because we are doing modulo subtraction. So modular subtraction is done in this method. Subtract something, then add it by 1, by n, by which you are taking modulo, and then they take modulo. This is it. Our solution is accepted. Now let's move to the next problem. So in this problem, we are given with an array of length n, where each element is a positive integer or value minus 1. It is guaranteed that the first element itself is not minus 1. There are n people numbered from 1 to n. If the current element is minus 1, then not minus 1, then the ith person votes the number or member ai. If ai is minus 1, that's okay. If ai is minus 1, then person I looks at the prefix a1 to ai in the array. Consider only the positions uh, j smaller than I with aj not equal to minus 1. Okay, it looks at its prefix with all the values that are not minus 1. Now, if a person appears whose frequency is highest, alright, and it is unique as well, that is, its frequency is unique, that is, a person has 5 votes and all the others have smaller than 5 votes. If a single person has equal to 5 vote also, then he will not vote. Alright, if two or more values share the maximum frequency, he will not vote. Given a member X, determine whether there exists any valid rearrangement of known values such that X receives the unique maximum number of votes. Okay. We want X to win with this scenario. What is the scenario? Let's understand it. We are given voting system. It is happening in the voting system. If AI is not equal to minus 1, the person votes AI. Alright. If AI is minus 1, alright, the person votes the element or member with highest frequency in prefix. Alright, and this prefix does not contains of elements having minus 1. That is, a minus 1 person does not consider the vote of another person which is having AI as minus 1. Alright. Now, what do we want? We want X to win. Let's try to maximize the probability of X to win. So how will this happen? If only X appears in the starting, then frequency of X is maximized. Now let's say there are 3 Ys and 4 Zs. Alright, what will we try now? We will want that frequency of Z and y should never be equal to or exceed x. If it does, it should happen as largest or as far away from starting as possible. The element with max frequency should appear as, or let's say, with frequency equal to frequency of greater than equal to frequency of x should appear as far as possible. Right. How can this happen? Let's try to have a construction for it. Like we want the frequency to be as small as possible for the rest number with equal probability. All right. So what if we pick one y, then one z, then one y, then one z, then one y, then one z, then again one z. All right. So with this, what were the other possible scenarios we had? Like we could insert all the y's first and then z's. But this was a problematic scenario. Let's say y was also 4 and z was also 4. So this transforms as this, while this transforms as this. So what is the first index at which a person apart from x has a frequency equal to 4? Here x, only x has frequency 4, x and y and z has frequency 1, 2, 3. Then here at this particular scenario, y has frequency 4. Now, if a person or minus 1 appears after this y, he will not decide to vote. Alright. While if a minus 1 appears here, then even till this scenario, x has highest frequency. So he will always vote x. Alright. So while in this scenario, if a minus 1 appears here, this that we have added one vote to the vote base of x. All right. How? Because y and x have same frequency here. So this person will not vote here. While in this construction, this person will vote. So this construction is always the best possible construction. Try to minimize the frequency of all added new elements after x's. All right. How to do this? Insert new elements every time. How to do this? What do new element every time means? While that is, if we have 5 elements with frequency 1, then insert all the 5 first. Then we have 3 elements with frequency 2. Then insert all these 2 elements. That is what we are doing. Alright, 2 elements at frequency 1, so insert both of them. Now 2 elements have frequency 2, insert all of them. 2 elements have frequency 3, then insert all of them. What do we achieve by this? We have try to make the first element having frequency 4 as far as possible, all right, with this construction. And if using this construction x wins because this is the best possible construction, then he wins, else he always loses. All right. So one like a thing that is to be noted, that AI's value is 100 here and not n. That is, a person does not vote among themselves. The voting person does not vote among themselves. A person who is not voting can be voted as well up till 100. So keep that in mind while implementation. So let's move to the implementation part. So take the vector as input, create a map to have frequencies, Now mark the frequencies inside our map, create a vector to store all elements in this order. Right? Try to create this order. Remove all minus ones for now. Create this order, that is inserting all x's now. Then one by one inserting all the elements, doing round robin. That is like inserting elements with frequency 1, then frequency 2, then frequency 3. Alright. So uh, we create a temporary array for that construction. First, what do we do? Insert all the x's. How many x's are there? It is equal to mp1 of x. Push that inside our temporary array. Now create a vector. Its term is at term it as now. What does this now mean? What are the number of elements having frequency 1? Alright. How many persons can be voted? It can be one from 1 to 100. If this person has at least one vote, at least one frequency, push that inside now. Alright, because what we are doing, this yz is one part, one subarray, all elements having frequency 1 now. Then this yz is another subarray, all elements having frequency 2. So this particular subarray is represented by now. Alright. So initially first with one frequency, we have created now. Now iterate over all the possible frequencies. What are the possible frequencies? From 1 to n. Element can have at most n frequency. Now create a vector named next. Alright, next represent what will be the elements in the next subarray. This is the first subarray. Create elements that are present in second subarray. Iterate over all the elements in now. Insert it inside our temp. Now, if this element has frequency greater than I, that is, it will be available in the next subarray. Alright. At the end, after this iterations, now will be equal to next. Now let's make vector. Let's insert these minus ones. We had already initially removed these minus ones. Now let's change vec such that the ordering of all these elements except minus one are according to this particular construction. Okay, so what is the first index, current index in temp that is to be filled? It is equal to 0. Now iterate over all the elements in vec. Initial vector we had. If the current element is not minus 1, then only we can replace it or construct it. This element is equal to temp at index. Right. So we have done the construction of vec according to the required construction. Now let's check if our x can win or not. Okay, so vote 1 denote total vote. Right? Let's say total and vote. Like vote denotes what is the number of votes in prefix, not considering the minus ones. Alright, and total denotes the total number of votes taken till now. Let's keep maximum value as 0 initially, and the person with maximum value as 0 initially. Alright. Now iterate over all the elements of vec. If vec equals minus 1, that is the person sees from prefix. So if the prefix is not saying that the person with maximum frequency is 0, that is it exists, then give a vote, total vote of that person increases. Alright. What in the else part? If it is not minus 1, then whatever that person is, he increases or he gets that vote. Total vote of this person also increases. If the current maximum is smaller than vote of current person, then maximum value change and the person also change. Correct. What in the else part? Maybe maximum value equals a current value. Alright, what happens in this case? The person do not decide to vote, and a person do not require decide to vote if p value is 0. Alright, so fix p value as 0. At the end, check if x has won or not. Let's say he has won, and if any element from 1 to 100 has got the same or more vote than x, if that element is not equal to x and the total vote of I is greater than equal to x, total vote of x, then flag is equal to 0 because he cannot win. If flag exists, print yes that he can win, else he cannot win. Right. This is it. So okay, so we have not taken x as input,